Hello, everyone. How are you doing? I trust you're all doing great. James from JT Smith Tutoring here. Today, we are going to be looking at a linear system of three unknowns with exactly one solution. So I bumped into this brain teaser online, and I know this can actually be solved in less than 30 seconds, but I'm not actually looking at it from that angle. I've just decided to use it to help us understand linear systems. So let's get going. All right, so on our first scale, we've got a mouse and a cat and their wing, 10 kilograms. On the second scale, we've got a mouse and a dog and their wing, 20 kilograms. And on the third scale, we've got a cat and a dog and their wing, 24 kilograms. So they want us to find out the total weight here. Okay, by substitution here, let the weight of the mouse, the cat, and the dog be X, Y, and Z respectively. So X plus Y is going to be equal to 10, X plus Z is going to be equal to 20, and Y plus Z is going to be equal to 24. So from 1 and 2, X is going to be equal to 10 minus 1, and X is going to be equal to 20 minus Z, respectively. This implies that 10 minus Y is going to be equal to 20 minus Z, which is my fourth equation here. So from this fourth equation, Y is going to be equal to Z minus 10. So you plug in Y is going to be equal to Z minus 10 into equation 3. All right. So Z minus 10 plus Z is going to be equal to 24. 2Z is going to be equal to 34. Z is going to be 17. This means that 17, this is the total weight, not the total weight. This is just the weight of the dog, okay? All right. So you plug in Z is equals to 17 into 2 and 3. You've got the weight of the mouse being 3 kgs and that of the cat being 7 kgs. Thus, X plus Y plus Z is going to be equal to 3 plus 7 plus 17, which will give you a total of 27 kilograms. That is the total weight of the three animals. Beautiful. All right. We go on to elimination. All right. We are making use of the very same equations. Subtract equation 2 from equation 1, we get Y minus Z is going to be equal to minus 10. And from there, it implies that Y is going to be equal to Z minus 10, which is my equation 4. And we've seen this before. The rest is actually history. We can actually do it the same way we've done on substitution. All right. You may also start by eliminating Z. That's by subtracting equation 3 from equation 2. So I have left that one for you. Show me your pencil signature there. Wonderful. Remember, at this level, we are introducing you to matrices now. We are trying to solve all these linear systems. This time around, making use of matrices. So let's get going. I have here Gauss-Jordan elimination here. Remember, we've got Gauss elimination, which will convert a given augmented matrix to raw echelon form, and we've got Gauss-Jordan elimination, which will convert to reduced raw echelon form. Take note of this. Raw echelon form is not unique. What do we mean by that? We can have different raw operations and even come up with different matrices in raw echelon form. But reduced raw echelon form, it is unique, meaning that regardless of what raw operations which you have, we are supposed to come or to conclude or to arrive rather at the same matrix in reduced raw echelon form. Okay, having said that, look at the raw operation, these raw operations, but I have this matrix in reduced raw echelon form here, and we can see that the corresponding system of equations here is X is equal to 3, Y is equal to 7, and Z is equal to 17, which is exactly what we got when we used the method of substitution and elimination. All right, beautiful. Now I've also decided to solve the very same system using what the matrix equation. We've got AX is going to be here, where our B is, this is the total weight of those various animals. And obviously, I've got my matrix of the unknowns here, and I've decided to call this matrix A, okay? So guys, there are different ways in which you can actually get to the inverse of a matrix. So I'll leave that one for you, but I've already worked it out, and here I am. And you can see from everything that we have here, the total weight is 227 kilograms. Boom. Did you see that, Jimmy? You threw that mouse away. All right, guys, allow me to do what my mama taught me. A good visitor knows when to leave, or should say a good dancer knows when to leave the dance floor. Adios, amigas and amigos. Till we meet again, be rest assured that at JTS, we are committed to keeping you mathematically informed. Bye-bye.